Good morning, everybody. Welcome back to what is going to be our last video in the Advanced World History curriculum. So I know that this hasn't been the ideal situation and we've missed out on a lot of really good in-class kind of stuff that we should have been able to do. But of course, the current situation that we find ourselves in didn't really allow for that to materialize here in the spring of 2020. But hopefully this video is going to be good for you. If you like it, please leave a like, share it if you'd like to share it, subscribe to the channel so that you get notifications for when new videos come out, because I will continue to produce content as often as I possibly can. Today in this last video for Advanced World History, what we're looking at is science and technology in the contemporary world and what's been going on when it comes to the development of modern science and technology. And so we're basically going to look at this in three different ways, or three different venues of technology. First, we're going to look at the space race. Then we're going to look at computers and the rise of the internet in the information technology sector. And then we're ultimately going to leave off with biotechnology and maybe what the future is going to look like for us. So, starting off with the space race, of course, the space race is very closely connected to the Cold War at the end of World War II. Really one of the leading countries in the world for space technology was Germany, and the United States and the Soviet Union both took very, very specific programs in place at the end of the war to make sure that they each secured as much technology and as many scientists from Nazi Germany as they possibly could. And so, of course, the United States actually had a really big advantage here because the United States captured Wernher von Braun, who was the leading rocket scientist in Germany. We put him in charge of our rocketry program in the United States with the intention that, of course, we could help facilitate that technology in delivering nuclear weapons in the future, and also just for the pure science of exploring space beyond that. So in July of 1950, then, the first really humongous technological breakthrough came from what we're looking at here, which is the first successful test of a two-stage bumper rocket. And so what that means is a rocket that has two stages initially has the entire rocket body with an engine on the bottom of it, and it shoots up into the atmosphere. But eventually what happens is it runs out of fuel. And so the bottom segment of that rocket's actually going to break off and fall back down to Earth. And the second stage, the top of the rocket, will continue with the fuel that's remaining and the engine that's attached to that second piece. And ultimately it makes it much more efficient because once you get up into the upper atmosphere, you don't have as much drag, you don't have as much resistance to changes in velocity, and so you can have a much smaller spacecraft. The big section gets you up into the upper atmosphere. The second section then continues you on your journey. Once we could make that technology work, then the possibility of exploring all the way into outer space became much, much higher, and the United States was the early leader in the early 1950s. From there, though, what we see is the next really huge breakthrough that we need to worry about was in 1957. This particular technology is called Sputnik I, and it is the first man-made satellite ever created that successfully orbited the Earth. And it sent out radio signals, which you could find on an amateur radio, and it circled the Earth. And the problem with this one, though, from the point of view of the United States, was it was not created by NASA. Sputnik I was the Soviet Union's first opportunity to make a huge technological contribution in the space race. They did this in 1957, which of course is 4 years after Stalin died, and this is under the new science and technology programs of Nikita Khrushchev. The thing that really concerned everybody was this was the Soviet Union. This was supposed to be a backwards communist country that really didn't have any technological expertise, but that country was the first to put a man-made satellite into orbit. And so it really shocked people that, oh my goodness, the Soviets are beating us. Beyond that, then, November the 3rd of 1957, Laika, who's the dog that we're looking at here, actually became the first animal to successfully orbit the Earth. And of course, this was also an accomplishment and an achievement of the Soviet Union. Following that, on April 12th of 1961, the Soviets launched a cosmonaut named Yuri Gagarin, who became the first human being to successfully orbit the Earth. His flight took 1 hour and 48 minutes, and he orbited the entire Earth one time. But again, when the Soviet Union is having victory after victory after victory, the United States really feels as though we're falling behind. And so very quickly thereafter, of course, we start to massively ramp up NASA. February the 20th of 1962, John Glenn became the first American to orbit the Earth. And what this did then is it turned the space race into another area of competition in the Cold War. And so President Kennedy, of course, very famously said, since we've fallen behind, we're going to set the highest goal possible, and we're going to make it to the moon before the end of the 1960s. To accomplish that, then, they started what was called the Apollo program to successfully get human beings to the Earth and back. On July the 20th, 1969, Apollo 11, the 11th mission in the Apollo program, successfully did that. Now, we got a couple of important things out of the Apollo program. The first one, of course, was this photograph, which they call the blue marble. They turned their cameras back towards the Earth on their way to the moon, and they showed us this photograph. And this was a big deal because this is the first time that anybody ever saw a view of Earth like this. And of course, we're used to seeing things like this now, so it's not as impactful on us as it was on people at the time. But when you look down at that and you realize, oh my goodness, everything that's ever happened to anyone has happened there. That's everything we've got to live and survive and to make ourselves, live. It's all right there on a very, very small little pale blue dot in the middle of this vast ocean of space. And it really gave people an opportunity to develop some perspective. What's really important? What's really worth fighting about? What's really worth pursuing? In 1969, then, Apollo 11, of course, successfully landed on the moon. The famous phrase that he uttered was, that's one. He stepped down off of the bottom of the ladder onto the surface of the moon and said, "That's one small step for man, one giant leap for mankind," because, of course, he became the first human being ever to walk on something that wasn't Earth. Now, since the time of the 1960s and the Apollo moon landings, we have seen a couple of other really big developments in the space race. The really crucial one, and the one that's kind of most impressive right now, of course, is the International Space Station. This was a collaborative work from several different countries. Most of it was paid for by the United States, and most of it was orchestrated by the United States. But we led an international effort to create the first permanent human presence in space at this kind of a scale. The International Space Station, of course, is in orbit all the time. It is continuously manned by people from the international community that created it. They're constantly running experiments, and really we're looking at this more and more as kind of our hub to get from the surface of the Earth into outer space, and then eventually, of course, our goal is to go back to the moon and to go back to Mars, and hopefully that's something that's going to happen. So that's the history of the space race. And of course, hopefully in the future, by the time I retire, I'll one day be able to teach my students that, how the new Orion program took us to Mars, and how we started to successfully colonize that and to develop things on the moon and all that sort of stuff. But again, we'll find out about that together because we're all going to live through it at the same time. And as of right now, in the spring of 2020, I really can't tell you what happens in the future. Next, we're going to look at information technology and computer technology. What we're looking at here is called ENIAC, E-N-I-O-C. This really was the world's first electronic computing machine. And what you can see here is it's actually the size of a relatively large room. All of these switches and devices were responsible for doing, relatively what we would think of today as relatively simple mathematical computations, but all of them were being done electronically. After ENIAC, then, the goal was to make it more efficient, to make it easier to use, to make it smaller, to make it more portable, because, of course, the way that you used these early computing systems was you used punch cards. The punch cards would have holes in them in a certain configuration, and one at a time, in the right direction, you had to feed them into the machine so that it could go through the computations, and then eventually it would provide you with the answer to whatever the question was. What we're looking at here is actually 5 megabytes. Not gigabytes, megabytes. 5 megabytes worth of computer data in 1953. Now, if you think about it, your phone right now can download about 5 megabytes worth of data probably in about 10 seconds or less. It would have taken a week to feed 5 megabytes worth of data into this computer system. So think about how much that's changed. This, by the way, was only in 1953. So only 60 years ago, that's what 5 gigabytes worth of computer data looked like. Whereas now your phone can literally download it wirelessly over the internet in less than 10 seconds. That's an incredible increase in technology. And really, when we look at the increases in technology, and I'm just going to show these relatively quickly, we can see that this growth and acceleration in technology is getting faster all the time. The internet, of course, is one of the huge accomplishments of human beings. It interconnects the entire planet all together, all at once, simultaneously. I mean, we don't think anything about the fact that we can find out the exact temperature and weather conditions of any point on the Earth instantaneously, and we can do it now, of course, through voice control. The internet itself was only actually a project that was started in the later part of the 1970s. It wasn't privatized and allowed to be used by regular people until the early 1990s. And since then, of course, this enormous increase in things like social networking and the interconnectivity, the now upcoming Internet of Things, where of course you can use the internet to unlock your front door and to monitor, what's going on in your home and with security. And of course, now we also have things like drone technology, which is all interconnected with this sort of thing, to deliver products, automatically to your house from a relatively local warehouse. I mean, it's getting now to the point where we're starting to talk about what is called the singularity. The singularity is considered to be the point at which technology and human beings merge together into one, with thoughts being that, if you think about your brain, the human brain, as being little on and off switches, right? Each cell in your brain is a little on and off switch. There's only about 1 billion cells in your brain. So if we can take 1 billion transistors and have those simulate the experience of what a human brain does and how a human brain functions, the question was going to be, is that going to be a human being? Will we be able to download our consciousness? Will we be able to download ourselves into a piece of hardware? And then ultimately, if we move beyond, physical meat bodies into digital technology, what does that do to human beings? If we don't have to die anymore, does that still make us human? And again, that's something that, we're working toward, and we're working toward it in a constantly advancing way, to the point where this is really exponential growth, right? And when we look at this particular one, it shows the amount of time required to develop things. It took more than 10 to the 9th years to develop life. It took 10 to the 9th more years to develop eukaryotic cells, right? Multicellular organisms. Art, it took 10 to the 4th. Writing in the wheel took about 10 to the 3.5, right? The Industrial Revolution took 10 to the 2nd. The computer took less than 10 to the 2nd. And of course, the personal computer took less than that and less than that, and smartphones. And I mean, this advancing technology continues on and on and on until the point which we refer to as the singularity, where biological life and technological development really become one and the same. We're working on things now like nanotechnology, where incredibly infinitesimally small machines could be injected into your body to go and fix problems and to run autonomously to keep you healthy. And again, what does that future of technology hold? Well, the technology part, of course, has been really amazing. The other side of that is, of course, the biological side. A couple of the really, really super important developments here were in the 1950s. These two fellas, whose names are Watson and Crick, in addition to their research assistant, who is Rosalind Franklin, the three of them together conducted a series of experiments in which they were able to determine the actual chemical structure of DNA, which of course is the coding for all expressed protein synthesis and the creation of all living organisms on planet Earth. When they came up with the proof for how DNA is put together, people started to work on, well, what can we do with it now that we understand it? One of the really amazing new modern technologies that we've seen really only in about the past 20 years is what we call gene splicing. Before gene splicing can really work, one of the things you have to do is you have to go through and sequence the entire genome, so all of the different genetic codes for an entire organism, and then you have to start figuring out what they do. But once you do that, we actually have the technology now to be able to send some enzymes into that DNA, find the particular code or the particular gene that you want to use, and extract it. And then once we extract it from that DNA, we can start putting it into other kinds of DNA. And the technological ability to do that is incredible, but also the consequences of that are really, really amazing. And it's going to fundamentally change the way that the world works moving forward. So one of the first things that they did with this is they actually determined the specific gene necessary for a lightning bug or a firefly to bioluminescently light up. They extracted that DNA for that bioluminescence and they inserted it into a tobacco plant. In South Carolina, there is an entire field of these that light up in the middle of the night just like a lightning bug. That's absolutely incredible, right? That we're able to do that we're able to take traits from one organism and to put it in and insert it into a completely different kind of organism. Later on, of course, they were able to insert those same genes into a mouse, and now the mouse can glow. We've used gene splicing to do things like create blue strawberries. Tastes just like a strawberry, looks just like a strawberry. If you close your eyes, you wouldn't know any different, but now we can make them blue. Then people started to work on, well, maybe we can figure out the genetic sequences and the genes responsible for things like, human organs like the heart. So one problem could be if I have a heart problem, I have to find a donor, or I have to find a match, or I have to find a mechanical heart, which never works quite as well as my own heart. People started to think, well, instead of finding someone else to donate a heart to me, what if we could just take my own personal DNA, find the segment of my DNA that codes for my particular heart, extract that sequence of DNA, and grow me not another heart, but another copy of the heart I've already got. And this is ongoing research, which is continuing all the way up until this day. And one of the amazing examples of where we've already found serious success with this is with this mouse. Here it's something very simple. It's the external components of an ear, but again, this is a stepping stone. This is a path to the future, and we understand, right, that technology is advancing in an exponential growth fashion. So when we can grow the external, simple portions of a person's ear, how long until we can grow the inner portions of their ear? How long until we can grow them a new liver or spleen or kidney or insert whatever you would like into that? The future is really going to be an incredible place to be, and I can't wait for us all to get there. So I hope that you've enjoyed this video. Please do like and subscribe if you did. I hope you've liked the whole video sequence, and I hope that you've learned a lot in my class. Leave a comment below if you've got any questions, and I will see you guys in the next series of videos. Stay healthy and stay safe, everybody.